good afternoon, good morning, whatever the time fits for everyone. So just before I start off, a few things. How many of you count yourself as web developers out here? Written at least some HTML running somewhere inside a browser. That's kind of enough for now. So few things we're going to be looking at today. And primarily, you'll see a mix of words out here. There's Chrome, something saying built-in AI. What does it exactly mean, right? So we've got a few things lined up, and the way we'll be covering it is as follows. So first up, right, we'll try and just break this into what Chrome built-in AI really means. And if you've got some definition yourself of what web AI might mean, is it like AI in the browser? Is it AI being done on the server and results being displayed inside the browser? We'll just clarify a few things precisely. What time up? It says time. Okay, anyway. We will sort of, okay, let me just again feedback. So we'll try and break down what Chrome built-in AI means, and most importantly, right, why? And that's important, so that you can precisely understand what's the use cases that we are talking about. Why has a team at Google gone ahead and trying to build something which says, let's bring in the models right within the browser itself, right? Which problems does it think that it solves? Again, why on the device? We'll cover a few things. I'm sure you have an understanding of what processing at the edge, processing locally, the benefits of that might mean, but we combine it with AI and see why some things on the device matters. Then obviously, we'll take a look at what precisely it is, some of the examples, some demos, etc., with a few things that I can call out to. You can try out later. Again, all of this, too many points. Ideally, I want you to go back with just two things from this talk. One is that you'll understand how to get started with Chrome built-in AI so that you can experience it yourself. And most importantly, right, if you are a web developer today, the point is, how do you sort of relook at your applications? How do you sort of maybe integrate AI into your web application so that it precisely helps you to solve certain problems which might have been traditionally difficult to address. So we'll actually cover a scenario where you'll participate and you'll just give me some suggestions that if this was your web application, how would you have maybe integrated some AI features around it? So these two things, if you go back with, that should be good. So let's first just split this into like the first point which said, right, that what exactly is Chrome built-in AI? How many of you have heard about this? Chrome built-in AI. I'm not going to ask questions. I'm just, okay. How many of you have heard about at least trying to bring AI to run inside the browser? Most of us. How many of you have obviously seen this diagram? Some form of it. That, hey, AI is too expensive, too difficult to do on the client side. It's better that you use CPUs, GPUs, TPUs, whichever you use coming on the server, send it there, get the results, and then display it in the browser, right? So precisely this diagram, which you're seeing right now, is, that you've got your web application front end there on the right-hand side, but really the magic is happening on the server side. So send a request, let something happen there, whether it's inferencing, etc., get the results, and then you display it over here. This is actually just what, or let me step back up, but this is not what we are going to be talking about, right? Because this model really says everything is happening on the server, it's just getting the results and displaying it out here. But this model is still important for you to understand. So there's been a move towards what you're seeing here, which is, even though you're in the web browser, let's get some of the processing to be done inside the browser itself. So you would have heard about methods to download the models, do the inferencing inside of the browser itself using maybe one or more of these technologies which you see out here. And also, you have to grapple with the fact that, do you have enough stuff on the browser, on your local machine, to even run some of these things? So would it require a GPU? Would it require something else? How many of you know what an NPU is? Or did I make a typo and it was something maybe else? Okay, but if not, maybe that's, I won't tell you what it is, not that I'm going to be covering it, but just look it up. It's something Quite interesting. So anyways, the point is, there have been attempts, there have been solutions that you have even today, which let you do some of these things, which lets you, get the models and run them inside the browser. But why would you do that? Or the better question to ask is, there is actually a problem with this approach. So for example, if you built the, let's say you built a you fine-tuned a model, you've done something great on the server side, and now you say, I want everyone to actually download this onto the browser and run it, because everything has to happen on the browser, so it requires you to download it. So just, a question here, what you're seeing. How many of you visit, or not how many websites do you visit on an average in a day? Just some numbers. 5, 10, 15, who knows? Maybe it's not going to be 1, 2, right? It's going to be quite a few number that you visit on a daily basis. Just think of those as these sites which you're seeing here. Now, what if everyone starts telling you that you've got different LLMs? In order to run that stuff in your browser, you will have to download an LLM for a site 1, LLM for a site 2, LLM for a site 3. These sites don't really share their LLMs if they are like, something unique that they've made. As a result of which, you see the problems that you're likely to see over there, right? How many of these times are you going to keep downloading all of these things? Do you even have storage? These models are not small, as you know, right? We're talking of several megabytes if they have been really, even tuned well, or could be even greater than that, right? So one is a whole delivery problem, which is that for a user, for an end user, right, you just can't keep downloading all of these models onto the browser every now and then. I have not even got to the point of saying what would be the experience to wait for something to download before the thing actually works. What would be the methods or the experience for you to even upgrade these models in case there are changes? I'm not even getting there. Hopefully you get the picture that this itself is not very suitable right now. What happens moving forward, we don't know. But at this moment, this is a real problem. This is not just from an end user perspective, but think of it if you were delivering it. So you are the one that owns this site, correct? And your app has got popular, or the web application has got popular. And as part of it, you've got an LLM that has to be downloaded by users. So what happens is something like this. You've got 3 users, maybe you've got 1 million users. Now, this means that even from a point of a publisher, you're going to end up with high serving costs. For those of you who've deployed anything on the cloud, understand something like an egress, ingress, all of those things, you can't expect millions of users starting to begin downloading your model. I'm not saying that all approaches today to download a model are wrong ones you should not go for, but you need to understand at scale, especially when models keep changing, especially when you are not even sure whether the users have the capabilities from a hardware perspective to even run these models. There could be so many just experience issues that could just destroy the whole process, right? So given all of this, right, the solution that I'm leading towards, right, is what the Chrome built-in AI is about. So this is a picture you need to keep in mind, that it doesn't matter what these sites are doing, right? We are not talking about them delivering custom models. This is a reverse which is in the browser itself. You've got the Gemini Nano model that is shipped, right? So you actually have a version of the Nano model. Of course, it's not just a version of Nano model, but I also talk about certain tasks that it is well suited for. These are now part of the browser itself, right? So even today, with Chrome built-in AI, that's the approach that is being taken, that the browser itself will ship with these models. When it comes to running the code, it's going to figure out what's the best way to run it onto the hardware that the user actually has. Again, I'll come to how they've chosen the model, where they're focused on, but just go back with this picture of the current problems that we've talked about in case you were to download all these models and start running it, versus this approach where the model is shipped with the browser itself. And that's really Chrome built-in AI. Now, of course, we are saying now that here's the browser, it's got the model in it, And why is that really important, right? Let's just forget it. Let everyone download. Let's assume in the future that network speeds would be so good, models would be so well distilled and fine-tuned and made smaller in size that it just doesn't matter, right? Even if we get to that, what are some of the reasons why you would still want to run all of this stuff locally? And here are some points, and I'm sure you're pretty clear about it. One is privacy, right? So if you are able to run something locally itself, there is no question of it going even out of that to do it. So for example, you can even say, let me prompt my own emails and try to search from it. Or let me talk to a local server that has basically my own data and can it sort of give me some things on top of it. Here, there's no question of it going up. Maybe the users might be more, I would say, amenable to doing when there is privacy involved. Performance, of course, is going to be local. All of you know currently calling any LLM, seeing the speed of what happens. Even right now, you may still argue, seeing something work in Chrome built-in AI, that it's still slow, but still, it's local. It's only bound to improve. But performance definitely is one. Offline availability, this is also given. Again, these are not something that's unique, to Chrome built-in AI or something, but you get really things that work offline. The benefits of that sort of flow into this. Cost. Everything is run locally. We're not even talking of any server-side processing that's going to come up over here. Zero install, okay, nothing much to do because the browser itself is coming with those models. So that's the zero install we're talking about. We're not talking about any other specific things. And of course, you have the benefit of the reach and scale of the web itself, right? So having said all of this, we've tried to give you some picture about, of course, why it matters on the device, but really the current approach with just downloading blindly some models to be run locally and executed. So this is the thing which I mentioned earlier. So if you were the team that had to come up with a version of the Gemini Nano model and had to run it or ship it, first of all, with the browser, where would you sort of tilt the scales? Would you focus on quality? Would you focus on performance? Or would you focus on devices to be reached? For example, the web, who's running your application, you really got no clue. You don't even know what the capabilities of their hardware are on which the browser is being run. So if you focus too much towards trying to reach as many devices as possible that people are using, you may start compromising a little on the quality and performance. If you want your models to really be high quality and perform well, chances are they may not be able to run on as many machines. So there are some trade-offs that the Chrome team had to do, that in case we have to come up with a model, like how do we even go about, right? Are there certain use case approach that they should take that, okay, let's see what are the problems people want to solve, what are the things developers want to do with these models, and those use cases, if they can run well, maybe that's the kind of model we need tuned that goes with the browser. So these are the points. I'm just giving you a picture so you understand. Even if you had to get a model of yours to run inside a browser, keep in mind these 3 points will come up. And usually it's like you can't get all 3. You'll have to go somewhere in a spectrum that balances a bit here and there. So this is the approach that's been taken. And I mentioned about use cases, right? So the point is it should perform a bit. It should reach as many devices also as possible. But most importantly, let's address certain use cases. So it's not going to be like, hey, I just want a model to be there in my browser. What are the things that it can actually do, right? So that brings to the next point, that the Chrome team then actually invited folks. It was like a 1 or 2 week sprint that tell us what are the problems you want to solve, what are the things you expect a model to do inside of the browser, so that we focus on those use cases. Accordingly, we create specialized APIs. Because for developers, they don't care about what shipped. Okay, if you just say, hey, there's a nano model shipped inside the Chrome browser, they'll say, so what am I supposed to do with it? Are you giving me high-level web APIs, which I can just integrate into my application and do some things? Are you going to be giving me a general prompt API that says, just prompt it, tell me what to do, and I get the results? Are you going to be addressing very specific APIs that use the model behind the scenes? Because unless you can give a simple web API that developers can use, the adoption is not going to really fly. And you'll see later when I show you some of the code that it's hardly a line or two. The abstraction is so well made that, like for example, a prompting, or you say dot summarize, or you say dot translate, right? And behind the scenes is still using all of these things. So these decisions were there, and that brings to these use cases. So when they had a 2-week kind of a sprint, right, with certain partners, that what do developers want really? If a model is shipped inside of the browser, you will see typical, use cases that came up with. So again, the point is, it can't be that give me like these 10 APIs, or give me like very complex kind of APIs to do this, right? So it should be something, maybe if summarization is the thing to take, it should be as simple as dot summarize, do it, right? And behind the scenes, it calls it. So again, not all of them, again, were taken, by the way, by the team. So what you see today in Chrome built-in AI, the APIs that are available to you are a few of this, not all, along with a general prompt API. So that in case you don't have it very specific to this, you can still prompt it, get used to a bit of prompting, and you'll be able to see the result. So this brings me to what is available today in the Chrome built-in API. So obviously, if you take the Chrome Canary version and download the Nano model into it, then you will have certain APIs already enabled. And those are as follows. I'm just putting it up here quickly. So first up is a prompt API. That is, we don't know what your use case is, but try the prompt API and see if you are able to come up with a specific use case and etc. But the others are very specific. You want to summarize inside of the browser, you have a summarize API call. Language detection, translation should be straightforward. Writer, rewriter, literally, like you would have heard these words, agent and agentic and multi-agents and things like that. You can actually start with some text, tell it to write, and then you can say rewrite. Then you can say write it again. So there are writer and rewriter APIs available that it can take a piece of text, maybe write it in certain forms, or rewrite it to say either make it concise, make it more detailed, make it more casual, whatever be. So there are several parameters like that. So at the moment, you get these things that are there in the Chrome built-in API. We'll see the demos, so it should become straightforward. So at a high level, before I start going into other areas, if you just want a highly technical kind of a way to look at it, that's what's happening in the browser there. So you've got Chrome, you've got that Nano model, possibly with some fine-tunings and tasks that are available, and they're splitting it up into task APIs, so like summarize, rewrite, write, and exploratory APIs, which is the prompt API for now. So as and when more use cases get discovered precisely with the prompt, they may move it into the task API. AI runtime, that does it automatically for you. So from a web developer perspective, you may not need to worry what happens below. Depending upon whatever be the capability that's out there where the browser is running, it will accordingly run that stuff for you. So given this picture, I'm just going to shift to gears a little bit and then come back to the Chrome-built APIs to see how they work. So again, what you see over here is obviously every time we talk about AI and we say everything should be into AI, etc., but ideally, what you want to do is, please tell us what's the problem that you are trying to solve, right? Versus just trying to promote this. And to sort of lead into that discussion, I'm not sure how clearly this is visible. I can't zoom it further. But just think of this as a bug reporting customer issues kind of a application for now, right? And it's pretty straightforward. In a sense, you've got some issues that have been reported, correct? And some attributes, what type it is, what's the sentiment, what's reported by, etc., right? Now, I want you all to just interact with me for a moment, right? To sort of map yourselves to what is possible now, to do some of the things that we will discuss using the Chrome-built API so that it becomes clearer via a more practical example. Now think of it this way, right? How many of you have dealt with any web application where customers reported something or feedback or something, right? Or maybe a database of records, could be anything. How many? Or at least seen something like this, right? Now just assume for a moment you coded this. You had no control over what someone used as a language, maybe to report it. That's one, right? So you'll say, what should we do here? Folks, suppose if you, let's assume for a, I'll make some assumptions. That let's assume that the customer support people using this know only English. Suppose. So what would you do? You will have to first detect and you'll have to translate. Where would you do this? Google Translate? Where is Google Translate going to make a call? Where? Over the air, but somewhere, right? So again, the point is, could we have done detection of the language? And could we have also done translation locally, not making any other calls? So far with me on this, how potentially you could have done something with this. Next, take a look at the description. How many of you have got a bug report and you have cursed the person reporting it and said, couldn't they have written it better? Couldn't they have summarized it better? Things of that nature, right? What you're seeing over here are reported by the users. Or, sorry, the person who's reporting this bug. This by no means might be an accurate thing, whatever that could be. Or, how many of you said it's written almost like 10 paragraphs? Could I have just seen a summary? What if I just go and do a tooltip and it tells me what the summary is? Think of it for a moment. But all of that running locally. Again, not going outside, so basically you're doing it literally on the fly. You're not again saying when saved, that time summarize. Who knows, why summarize it when it may not be needed also? So again, you could have summarized it. Maybe you could have even checked if the sentiment is okay or not different. Even this, right? People write, all of us have reported issues. We've written a title, which has got nothing to do with description at times because we want to report it. But you could actually say, let me take this description and generate an alternate title that really summarizes it well and correctly, right? Things of that nature. Similarly, this type. If you're going to give a drop-down to the user to report what kind of complaint or what kind of department, chances are, could be right, could be wrong. Maybe you could even say, depending upon these two, I'll figure out, is it really of this type or no, right? So literally a few short kind of prompting or with some examples you can do right within the browser. What about search? How many of you have done search of this nature? So let me go to the same application that's there, right? Just observe. So if I do something like headphones, right? Simple, right? Filtering. But something if I do earphones, it doesn't. Could I improve this? Any suggestions how? You would have all heard about semantic search, right? So what if someone who's typing a few words, you actually map it to a more relevant, okay, it's earphones, could be the same, somewhat related or whatever. Maybe my example is not good, but you get the picture, right? Where you could actually improve these things also. Even lookups in a drop-down list when people are typing, unless you are exact, sometimes lookups don't match. But you could actually be smart, out there. There are also many other examples where literally you go to a document and you just, copy the whole block and go to a form and do a special paste and it extracts out the first name, last name, age, date, whatever it is, instead of you having to type out. So there are many things you could actually do, all local within out here. So having just set the context a little bit for this, we'll start now exploring the APIs. But first, how to get started, right? So obviously, there's a link, at the end, you can see all of that. But it's as simple as joining a preview program. And so if you just do Chrome built-in AI preview, you'll be led to a program. Joining the program has got nothing to do with enabling the features in your browser. It's only to get updates of what's changed, any new APIs. Most importantly, 2, 3, of course, will make or break you experiencing it. So one is check your hardware requirements. There are a few. I'll just jump a little bit forward. Here are some requirements right now from their official page in terms of what you need to have locally in your browser in order to run these things. So there's something to do with OSs and versions. Obviously, there are a few storage GPU requirements. You might get a little bit disappointed in case your current machines don't have those capabilities. But again, this is all preview for now. But once you've done that, obviously, don't take your chances with the normal release channel. You'll have to go and get the canary channel of Chrome, in which you can experience all of this. Set a few flags, as number 4 says, and then you need to download the model. And usually, if you just try to instantiate any one of these calls, it takes a while in the beginning. It's a little bit clunky right now because it's in preview, but later on, they'll probably improve the experience to get it with the browser itself. The moment you do that, it starts downloading a model, and then it says it's available. Post that, you can start using it. So a few steps like that once you complete. So for example, the hardware requirements, there are Chrome flags, as I said, each of the prompts. If I just switch to, right now here I'm in Chrome Canary, so you will see there's a prompt API for Gemini Nano, there's a summarization API, there's a writer API, rewriter API, translation API. So you just have to go and enable these. Then within your browser, you'll just be able to try out those things. So, sorry. So moving forward, right, we'll just see a few of these in action. So you just kind of see, oh, it was just a call or two, or maybe a method or two that we had to call in order to see that. So obviously, I've got Chrome Canary installed on my machine. And this is a GitHub link. So any of those projects, if you want to see all the source code that I'm showing today, you can go ahead and try it out. If you try it out, obviously, just make sure that you follow the instructions for downloading Chrome Canary and a few of those settings that you need to do, right? So having said that, let's kind of move forward with it. Prompt API. This is the experimental API. So you can try out pretty much anything that you like. So it could be like, give your prompt, get a response. It actually talks locally to the Nano model and gets the work done. So as you can see here, right, in order to instantiate the model, it's as simple as a create call. And remember, there's a system prompt, the context. Like, it just helps to lead the LLM towards the right area to answer. So you make sure that there's a good system prompt. It's a very naive one that I put here, but you can keep as much details. You can even put examples and whatnot if you want to, right? So I've just shown the very simplest way to do that. And here's a function. Again, it gets a review text, and you can see there, all you had to do was just call the prompt API. And that's pretty much what it is. You get a response back, and you then display it in your website of things. So again, the example that I've used here is, let me look at this. So I've just kept the Chrome developer console also on. So again, what I'm doing in Analyze Sentiment, nothing great. It's like once I click it, I just go through each of these entries, and I pass them this particular prompt, which is what you saw in this, which is, hey, analyze it for sentiment and identify what was liked, what was disliked. But it could be any prompt. It could be your own application also which you want. I'm doing this intentionally here so you can also understand, and because it's important, you'll see it doesn't run blazingly fast. It's running locally. And this machine is not bad, what I've got. But still, you'll see it takes its own sweet time. So we've got some 6 records. Yeah, 5 records. So I click this. Now it's analyzing one by one. And I've just held it. I could have written better web apps. You know I'm not a web programmer when you see me see code like this, and not a designer in any shape or form. So you can see it's taking its time, every prompt, one by one, right? And then, of course, I'll just dump all of that stuff into the sentiment, right? Again, you can see that this is all that has run locally. A complete prompt API, like a prompt model you've created, and you just prompted it with whatever details you want. Again, I've just shown it very rudimentary. If you can even take the markdown or any other formats, or you can use your prompt to say, give me only a list or whatever it may be. But this is all running locally. Next one. The reason, again, they've given the prompt APIs so that people can experiment. They want to know what are the use cases that are common, so that then that gets converted into a task API, like the summarize or translate or detect language. So the next one is that thing which I showed you, right? People could have commented in other languages, and you may want to first detect the language. Maybe that's the use case, you want to detect it, and then you may want to translate it. So if you see the first part, right? So here's a comment. That's the text that is passed. You're creating a language detector, a new kind of a very specific task that's out there. Again, behind the scenes, it's the Gemini Nano model inside the browser. So you create that detector, you detect the language, and then depending upon that, you may call the translate, which is also passed what language was detected. So again, pretty straightforward calls to do this. And the way you could have integrated this might have been, again, apologies on the way I write my code. But just to show you, actually, wait. This is the right way to show it. So you got, 3 comments out here. And the first thing is to just maybe detect what it is. Because when I do a translate, I need to say what's my source language and what's my target language. So the first task is going to be, can you detect this? This ran pretty quickly. It's all local here, right? Across these. And now it's known these are the languages. Again, be aware of the fact this may not support all languages at this point in time in preview mode. So I'm just being realistic with my expectations. And that's how it is. So again, here I could then do, something of this sort. Nothing out of the ordinary I'm showing here, but all of this, the detection as well as the translation, has run locally itself. So these are the things you could potentially provide. Next one. So we've done prompt API, we've got language detection, language translation, summarizer. This is an excellent API right within the browser, right? So you've actually got, how do you summarize? Is it just a TLDR, too long, didn't read? Do you want a catchy title? Do you want a teaser? Do you want a headline? Just key points? So they've given all kinds of types. Again, who knows, there may be more types in the future, but you can even say whether format is markdown or plain text or short or whichever that might be. And to summarize it is as straightforward as this, right? So how do we use this? Just to show you an example, it's, I think, over here. So I've just taken, a screenshot from the Chrome built-in AI documentation, the 2 paragraphs itself. And all we are doing here is just doing a summarizing now. So there are 4 models, 4 APIs instantiated, and then summarize called 4 times on each of these areas. And you'll see. So whether it's key points, any teaser, any headline. Now, it doesn't look like a headline, but yeah, you could further prompt it also to do things. But again, all of this running completely within the browser. And another nice thing which I just wanted to show was that these APIs now are supported even within Chrome extensions. So any of you folks are writing Chrome extensions and want to actually use these within the browser itself. So as a sample, right, let's be here on a website. And let's say these 2 paragraphs, so I don't want to read this, what does it really mean? So I've written a side panel Chrome extension which uses a summarizer API inside of it. So all I need to do is, you see this I've added, called summarize. And do that, it opens here, and then again it's calling summarize with some little thing. So again, that's another way you could do it. Again, just keep in mind, not all APIs are available immediately within Chrome extensions to use. So just sign up for this preview program because they tell you what's changed, what's added, and things of that nature. And what do we have still? Sorry. And finally, it's the same summarizer thing, But I was telling you, what if you could summarize a tooltip if you're going through a big description or something like that? So the same demo, I will just, where is it? Okay, here. You see this? Okay, let me show that to you. So I've refreshed it, right? So that you can see it takes a while to summarize, because only when I go into that area, then the tooltip is instantiated, then it does summarize and show you. So bear with me as it comes up. There. Right? So this is very useful. The reason I'm saying this is there within the browser. You could potentially use it. Even if you're not doing it that way, think about your web apps, right? And potentially how you could further improve upon it. And again, this title which you're seeing here is, see, sometimes, for example, I've written site not appearing well, right? But when I summarize it from the description, it's actually something else, which is also a way by which you can understand the problem a bit better. Okay. So call to action, right? That's the home page I was telling you. This is one single link you need to pretty much understand what the program is about. Sign up, download Chrome Canary, give it 10 minutes to download the first Gemini model, and you should be all set. Do not try this by mistake. I've spent enough minutes, enough hours, where I've gone to my normal browser, opened up this website, and seen why is it not working. You have to be in the Canary version. Again, there's a challenge if, in case, some big prizes, to be honest. But in case you feel like participating, that's there too. That's all I have from my side. Thanks.